Hey guys, these notes are for slope, the first section of notes for Unit 3. Our essential question is how and why do we measure change? Alright, so you should have learned about slope in middle school, but this is kind of just a reminder and a review, and then we're going to learn some new stuff today as well. So our first thing, we have a fill in the blank. So we have all linear equations, so any equation that is a line, so all linear equations have a constant rate of change called slope. Okay? And the slope measures the steepness of the line. All right. So we have 4 types of slope that we're going to learn about, and you should have learned about them a little bit in middle school, I think maybe in 8th grade. But our first type of slope is going to look like this, and that is called a positive slope. So from left to right, it is increasing. So increases left to right. Okay? Our next type of slope is one that looks like this, or let's draw a better line, that's ugly. And that's a negative slope. So it decreases left to right. Our third type of slope is one that looks like this. So it's straight across, and that is a 0 slope. So this is going to be a horizontal line. So if it is a flat horizontal line, it has a slope of 0. Okay? And then our final slope that we learn about is one where it goes up and down. And this is called undefined. And this is when we see a vertical line, that's when we know it's an undefined slope. So these are the 4 different types of slope that we see. It's either going to be positive, it's going to be negative, it's going to be 0, it's going to be undefined. So 0 is only when it's like lying flat horizontally completely, and then undefined is if it's completely straight up and down vertically. Okay? So a little bit of vocab. It's not really vocab, but it's basically the different ways you'll see slope represented. So the first way you'll see slope represented is rise over run. So you'll see rise over run, and we'll kind of talk about that in the next page of the notes. You will also see slope represented as change of y over change of x. That triangle is a delta, and it just means change. You might have learned that in science class. All right, another way we represent slope is by the letter m. When we see m, or if it's asking for the value of m, that's talking about slope. Our fourth way is when they say rate of change, which is what you probably used in middle school. So when you're asked to find the rate of change for something, it's just asking for you to find the slope. And then our last one is the formula for finding slope, which is y2 minus y1 divided by x2 minus x1. And you're like, what the heck is that? So we'll talk about this later in the section of the notes, but right now just go ahead and copy down that formula. But it's just a really helpful formula, and you're going to use it forever, probably for the rest of high school, to find slope. Okay, and those 2's and those 1's are subscripts, so they're baby numbers. It's like the opposite of an exponent. Instead of that baby number being at the very top, it's at the very bottom. And it's just kind of like the way we label things. All right. So the first way we find slope is when we have a graph. So when we have a graph, you're going to want to use the method rise over run. That's the method you're wanting to use here. Okay? Now, rising means we're going up or down, and running is left to right, right? When you run, you don't go up and down to run, you run across left to right. So first we're going to rise. So you want to start at a point. So I'm going to go ahead and start at this point over here that I highlighted in pink. And I'm going to rise. So let's see how many numbers I have to rise to get to the next point. So I have 1, 2. So I went up 2. And then to run, I'm going to go over 1, 2, 3. Okay? So I've gone over up 2, so I want to say plus 2. And then since I went to the right, when we go to the right, we always go positive. The left would be negative. So we went up 2 for our rise. So our rise is going to be a positive 2. And then our run was a positive 3. So our slope here would be 2/3. Okay? So here, is our number positive or negative? Our slope here was positive, right? 2/3 was a positive number. And it matches our graph. You see how our graph is a positive line? If we go up here, we see how in the blue we have positive. If our line is increasing left to right, then our number should be positive. So when we found our slope, we did it correctly. If you end up with a negative number, that's probably not correct. All right, same thing here, rise over run. Well, I'm going to start at this top point, and you're like, well, I can't rise any, the other point's below it. Okay, well, I can rise or I can also go down, so it's just the opposite direction. So instead of saying +2, I'd be going down and going minus. So I have 1, 2, 3, 4. So down 4 minus 4 for my rise. Go ahead and write that over here. And then I'm going to go over 1, 2 to the right, which is a +2 for my my run. So I went down 4 and then over to the right 2. And so my slope would be -4/2, but if I simplify that, that is going to be -2/1. So my slope here would be -2 or -2/1. We'll go ahead and put -2/1. Okay? And this makes sense. My slope should be negative because my line is a negative line. All right, moving on. So here we have a horizontal line. So if you already looked at the back of the notes, you would have been like, oh, slope of 0. Well, let's calculate this. Let's do our rise and our run. If I start at this point, how many units do I have to shift up to get to the next one? None. So my run here is going to be 0. Let's see what my rise is going to be. Or not my run. Oh my gosh, I just did that backwards. Horrible, horrible. My rise was 0. Let's see how much I have to run. Okay. I didn't have to run any. So let's go ahead, or I didn't have to rise any. I keep mixing those up. I am so sorry. Don't have to rise any. Let's run. So how many do we have to run to get to the next one? 1, 2, 3. Okay. I ran 3. Well, 0 divided by 3 is just 0. So my slope here is 0. And that makes sense because our line is a horizontal line. Okay. And if you actually want to think about it, I can actually show you a cool thing. You also know your slope is 0 because this line makes a z with the axis for 0, okay? All right, next we have rise over run is here over here as well. So our rise, let's start at this point. Well, I can't rise, so I'm going to go ahead and go down. So I have down 1, down 2, so -2 for my rise. And then for my run, I don't run anywhere. So I have -2 divided by 0. Well, if you do -2 divided by 0 on your calculator, on your graphing calculator, you would get error because you can't actually do that. Let me try it in my phone really quick. Yeah, so even if you do it on your iPhone or your Android, if you do -2 divided by 0, you're still going to get an error. That means we have an undefined slope. So our slope here is going to be undefined. There's not like there's not a slope, it's just an undefined one. And then the trick for this one is that this line makes a U with my axis. So if your line is vertical, up and down, you should have a U, and if your line is horizontal, you should have a Z for 0. And that's just kind of a helpful way to remember. And also, I don't know if you remember this, but I showed you this in like one of the very early sets of the notes. If I have 0 divided by 1, that is okay, but if I have 1 divided by 0, I can't do that, okay? If there's a number divided by 0, it's not going to work. But if I have 0 divided by a number, it's going to be okay. You're going to get a 0. All right, so that's finding slope using a graph. Okay, that's probably my favorite way because it's probably the easiest. All right, now we're going to find slope from 2 points. So this is the one where we're using that formula we saw at the beginning. So m, which is our slope, equals y2 minus y1 divided by x2 minus x1. Okay? Your y's are always going to go at the top. Always. So looking back, we did rise over run, right? Well, rise has to do with what values. When we're going up and down, what values is that? Well, that's our y-axis. And then our run is our x-axis. So you always have the y on top and then the x on the bottom. So here we have the same thing. Y on the top, x on the bottom. Okay. So here we have 4 examples. Find the slope of a line that passes through the points -2, -4, and 4, 8. Well, you're like, well, how am I going to use a formula with this? Okay, well, when you have 2 people in the same class, let's say I have an ordered pair here and an ordered pair here. They're clearly different, but they don't want to have the same name, so we have to name them different things, right? So I know that this is x comma y, and this one's x comma y. Well, if you have two people in your class, both named Emily, you want to make sure that you can differentiate between them. So that's why we have the little ones. So this is going to be, the first order pair is going to be our x1, y1, and the next one will be x2, y2. And actually go ahead and do that in a different color so we can see that a little bit better. x2, y2, okay? So we're labeling them basically. So our first order pair is going to be our x1, y1, and then the second one's going to be x2, y2. And then from here, we are asked to find the slope, so we just plug it into the slope formula. M equals y2 minus y1. Well, my y2 is an 8, and I put a minus. My y1 is a -4. Now, you want to put that in parentheses. Anytime you write the second number, I would recommend you put it in parentheses. And then our x's would be our 4, our x2 minus x1, which is -2. Okay. So all I've done is I've plugged in my numbers. Let me go ahead and label them for you. That's my y2, my y1, my x2, my x1. Now, these minus signs that are in blue, those are part of the formula. They're not the minus signs of -2 and -4, okay? Those minus signs are from the formula up at the top. Okay, you don't want to mix those up with your other numbers. That's why we have parentheses. Well, 8 minus -4 is going to be 8 plus 4, which is a positive 12. And then our 4 minus -2 is going to be 4 plus 2, which is a positive 6. So our slope here is 2 divided by 6, or 2. Okay? So that's the slope of my line, is 2, positive. All right. Number 2, we have to find a line that goes through the points -2, 3 and -10, 9. Find the rate of change. All right, so we're given a line, and it goes through these 2 points. Just like in the graphs we saw earlier, there was a line and there was 2 points that were there. We need to find the rate of change. Do you remember what the rate of change means? And if you don't remember, go ahead and look back at your notes, and you should be taking notes. Our rate of change is our slope, so we're just asked to find slope here. Okay, let's go ahead and label our points. We have x1, y1, x2, y2. I want you to label those points. If every time you see points, you want to label them, always, so that you can remember, get in the habit of it. It's going to be really beneficial for you. All right, so we're going to find slope again. We have m equals y2 minus y1, so 9 minus y1, which is 3. And then we have x2, which is -10, minus x1, which is -2. And notice how I'm still putting parentheses there because I don't want to make an error. I don't want to make a mistake. So 9 minus 3 is going to be 6. And then -10 minus -2 is going to be -10 plus 2, which is -8. And so that simplifies to -3 over 4. And you're like, whoa, why'd the negative sign jump up? Well, it doesn't really matter where your negative sign goes. Let me go on the side here and show you. -1 over 2 and 1 over -2. If I put these both in the calculator, I'm still going to get -0.5 no matter what. So it doesn't really matter where your negative is as long as you have one there. Okay? So it doesn't really matter where my negative is. I just decided to put it with my 3. So my slope here is -3 over 4. You always want to reduce. So always reduce if possible. Just like in the graphs earlier when we had negative, I believe it was -4 divided by 2, you always want to reduce. I just spelled reduce wrong. Reduce. There we go. All right, moving on. Find the slope. -1, 6, and -1, -2. So notice how all 4 of these problems are worded a little differently, and the reason why I wrote them that way is because you could see them a variety of different ways, and you should be able to understand what they're asking of you. Now, number 4, since you know you're finding slope, you're going to go ahead and find slope. They're not just going to give you 2 points and be like, here you go, do whatever you'd like. So obviously in number 4, we would definitely be finding slope. All right, number 3, find slope. So go ahead and pause the video to see if you can try this one on your own, and then unpause after you have completed the problem. Okay, so I have m equals, I don't know why that did that, m equals, and I need to label my points. So I have x1, y1, x2, y2. And I don't know if you've actually thought about this, but it doesn't really matter. I could have my first set of points labeled x2, y2. It doesn't really matter. Your formula is going to work out regardless of what the order is. But you can't just like mix them up. Like you can't say like, oh, x1 and x2 are together and y1 and y2 are together. So I could have labeled them x2, y2 and x1, y1. It doesn't really matter as long as your 1s and your 2s are together. Okay? And I'll actually even just leave it that way. We'll get the same answer regardless. Okay, so go ahead and do y2 minus y1. So we have 6 minus negative 2, which is our y1. And then our x2 is negative 1 minus negative 1. Okay? All right, so let's simplify this. We have 6 minus negative 2, which gives 6 plus 2, which is 8. And then negative 1 minus negative 1 is going to be negative 1 plus 1, which is 0. Can I do 8 divided by 0? No, it's going to give me an error. So what does that mean my slope is? My slope is undefined. Again, you don't want to say that there isn't a slope. There is a slope, it's just undefined. Okay? All right, and then lastly, number 4, we're going to find the slope again, and I suggest that maybe you pause the video so you can try it on your own. Okay, we have m equals x1, y1, x2, y2. Okay, so first we're going to do y2 minus y1, so negative 7 minus negative 7. And we have 4 minus 2. Again, I'm still using parentheses. You want to make sure that you don't want to make any mistakes here. All right, negative 7 minus negative 7, which is negative 7 plus 7, which is 0. And then 4 minus 2, which is 2. So then I have 0 divided by 2, which gives me 0. So my slope here is 0. Okay? So we found our 4 different types of slope. You can have a positive, a negative, an undefined, or a 0 slope. Okay, moving on, we have finding slope using a table. All right, so here we're going to use the other representation of slope, which is change of y over change of x. Still, your y's are still going to be in the numerator, your x's are going to be in the denominator. All right. Now I'm going to do my change of y in blue, and I'm going to do my change of x in red. So change of y. Basically, how are you getting from number to number here? I'm adding 1 every time, so it's constantly adding 1. And then my change of x, how am I getting from number to number? I'm adding 5. Okay, so let's go ahead and do change of y over change of x. The change of y basically means what number is, what's changing from term to term in my y's, and what's changing from term to term in my x's. So term to term in my y's is going to be 1, that's my change, and then my change of x is a 5. So my slope here is 1/5. Now it is very important that you don't mix it up, because I know that your x on your table is like at the top, so you want to put x divided by y, but that isn't slope. Your y divided by x is your slope. Okay, number 2, we're going to go ahead and do change of y, change of x again. So let's see what our change of y is. Well, from there I did minus 1, minus 1, minus 1, minus 1. So my change of y is negative 1. My change of x is actually 0. I haven't changed anything. So I have negative 1 divided by 0. Well, I can't do that in the calculator, which means that is an undefined slope. Okay? And that makes sense, right? If I try to graph this, right? Let's graph the first point. I have 2, 6. I have 2, 5, 2, 4, 2, 3, 2, 2. Right? That's a straight line up and down. So that is not going to be, that's going to be an undefined slope. I'm not going to have a defined one. So undefined. All right, number 3. Go ahead and try this one on your own to see what you get. Okay. Change of y. Well, how am I getting from number to number in my y's? Well, I'm not adding or subtracting anything, so it's going to be 0. And then for my x's, I'm adding 2 each time. So I have 0 divided by 2, which is 0. And if I graph that, all of my points are going to form a horizontal line. All right. The number 4 and 5 are kind of like word problems that you might see. And actually, you will see something like this in your homework as well. So number 4, we have a table. We have time in hours and cost in dollars. Is the rate of change constant? So let's figure this out. Well, change in y over change in x, right? Or let's just look at the rate of change. So slope is rate of change. Let's go ahead and underline that and say, like, okay, is a slope constant? Basically, is your change in y the same every single time going from number to number? And is your change in x the same thing going from number to number? So Going from number to number, what am I doing? Well, I'm actually adding 17 every single time. Right? We're adding 17. And then from here, I'm adding 2. All right? Well, my slope is constant, yes. So it is staying constant, and it's matching up. So we can say the cost is increasing the same amount every 2 hours, right? Because that's how many hours we're going by. So the cost, which is $17, it started at $17 and we keep gaining $17 every 2 hours. So yes, it is constant. Find the rate of change. Well, rate of change is just change of y over change of x since we have a table. What's my change of y? 17. What's my change of x? 2. Now, we're going to go ahead and simplify this, and that's going to give us 850, okay, or 8.5. But in this case, what does our slope mean? Well, time is in hours, so that's going to be our x, right? Our time is always going to be our independent variable, our x, because it's not dependent on anything. But our y is going to be our cost, because our cost depends on how much time. So in this case, when I get a slope of 850, that slope means that I'm making 850, or we're getting 850 every hour. Okay? Or 850 per hour. That's our rate of change. You don't want to just say 8.5. I want you to understand what it means in the context of the problem. All right, and then number 5, I want you to go ahead and try that one on your own. It is very similar to number 4. So go ahead and pause it and try it. All right, so first question is the rate of change constant? Well, let's figure it out. We have time and height, so let's first of all figure out which one's x, which one's y. Well, independent is always our x, and dependent is always our y. So what do you think is going to be the independent? What doesn't depend on anything? Time. Time never depends on anything. And height is going to be what's dependent. My height depends on how long, or the height of whatever this is depends on how long. So let's look at our y's first. Our change here. Well, from 850 to 820, we did minus 30. From 820 to 760, we did minus 60. From 760 to 745, we did minus 15. From 745 to 715 is minus 30. So already we're like, what is going on? Okay. Well, let's look at the x's. From 1 to 3, that's plus 2. From 3 to 4, that's plus 4. From 7 to 8, that's plus 1. And from 8 to 10, that's plus 2. All right, so right now this looks really funky, and you're like, okay, clearly this is not constant. Well, let's think about this. At 1 minute, we were at 850. And the table skips to 3, okay? So let's calculate for what 2 would be. We know that 3 is going to be 820. Okay, so what do you think I cannot speak. What do you think 2 minutes would be? What do you think the height would be at 2 minutes? Well, if I'm going from 850 to 820, and assuming that the rate of change is constant, and I know that the difference between this is minus 30, what's half of 30? 15. So what's 850 minus 15? That's 835, okay? So it skips that for us. But still, after each hour, or after each minute, I'm sorry, we're going away 15. We're taking away 15, and we're going plus 1, plus 1, okay? Same thing here. If we go to 8, we have 745. We don't know what 9 is, but we know what 10 is, which is 715, okay? Well, at 8, it's at 745, and at 10, it's at 715. That's minus 30. In the middle, what would we have? We'd have 730. It's still going down by 15. So our rate of change is actually constant, but our table is not constant. Our table skips some numbers, but it's still constant. So I'm going to say yes, my rate of change is constant. The height is decreasing the same amount per minute. Okay, and then let's find the rate of change. Well, here's the trick, right? for all the other tables, we looked at all of every single change. But honestly, you only need to look at 2 different values. So let me erase all of this. And let me show you. Just pick any 2 points you want. You could pick any 2 points. Let's pick 1, 3, 850, 820. All right, I picked 2 points. All you need is the change of 2 points. You don't even need to look at the change of the entire table. So, whoops. So from 850 to 820, my change of y was negative 30, okay? From 1 to 3, my change of x is plus 2. So go ahead and do change of y over change of x. That's going to give me negative 30 divided by positive 2, which is going to be negative 15. And so our rate of change here is going to be negative 15.
The construction.
So what does that mean? I am so sorry, Mr. Murdoch is at the door, and I don't think he read the sign that I'm filming right now. All right, so what does negative 15 mean for this rate of change? Negative 15 means that we are going negative 15 feet per minute. All right, Mr. Murdoch left. He saw that I was filming. I have a sign. I don't know why people don't read. All right. The last section of the notes is our word problems and then finding like a certain value. So let's read. The total cost, including tax of 3 cookies, is $5.50, and the cost of 8 cookies is $12.75. All right. So clearly we have to find slope, but what are we supposed to, we need to identify some things. Well, we know that 3 cookies cost $5.50. We know that 8 cookies cost $12.75. So what is dependent here? What depends? Well, like what are we dependent on? Let's just think about that. We need to figure out what our independent and their dependent is. Okay. So our dependent, which is going to be our y over here, the thing that's dependent is going to be how much it costs. So how much we spent. How much spent depends on x, which is our number of cookies bought. Okay? So number of cookies bought is going to be our x value, and then our how much we spent is going to be our y value. So I can actually go ahead and make ordered pairs here. I have my x and my x and my y. Okay? The first set of information I have is that 3 cookies is $5.50. Well, the number of cookies is my x, so I'm going to put 3 over here, and then the cost of that was $5.50. So then what do you think my other ordered pair is going to be? That's going to be 8 cookies and $12.75. So I actually have 2 ordered pairs here. And since I have 2 ordered pairs, I can use my slope formula. So I'm going to go ahead and label them x1, y1, x2, y2. Okay? So using my slope formula, I know that's y2 minus y1 divided by x2 minus x1. So let me go ahead and fill those things in. My y2 is $12.75 minus my y1, which is $5.50. And then my x2, which is 8, minus my x1, which is a 3. So I'm plugging in my numbers. I haven't done any math, I'm just plugging stuff in. Okay? 1275 divided by, not divided, 1275 minus 550 is going to give me 725. And then 8 minus 3 is going to give me a positive 5. And if I simplify that, I always want to check to see if I can simplify. That's going to give me 145. So what does that mean? It costs 145 per cookie. That's what my slope means here, or my rate of change. All right. And then lastly, our last 2 problems, we are going to find x given the slope. Sometimes you'll be asked to find y, but the process is completely the same. You just have a different variable that you're solving for. Well, I need to find x given the slope. Well, I know the slope formula. You're going to use the slope formula a lot, okay? So you're going to eventually at some point memorize it because you're going to use it so often. Okay, let's go ahead and label our points. We have x1, y1, x2, y2, and our slope, which is our m. So we actually are given the slope this time. Let's go ahead and plug everything in that formula in blue. So we have our slope of 3, so 3 equals, division bar, y2 minus y1, so 8 minus 4, or sorry, negative 4. I almost messed up there. 8 minus negative 4. And then x2, which x2 is just x, so I'm just going to put that there. And then minus x1, which is minus a positive 1. And then let me go ahead and simplify this. So I have 3 equals 8 minus negative 4, which is a positive 12, and then I just have x minus 1. And you're like, well, I still don't understand how I'm supposed to simplify this. Well, 3 is technically 3 over 1, right? And do you remember in middle school when we did cross multiplication? That's basically what you're going to do here. We're going to do cross multiplication. Okay, so let's do the first one first. 3 times x minus 1 equals, okay, and I'll keep that in purple. Actually, I'll change it. Let's do yellow over here. The yellow part, which is 1 times 12, which is 12, okay? That's so hard to see. I give up. Okay, we're going to do 12 here. Okay, so we have 3 times x minus 1 equals 12. And then you want to go ahead and start solving. So when I see 3 times x minus 1 equals 12, the first thing I want to do is distribute. So then I have 3 times x, which is 3x, and 3 times negative 1 is negative 3. Okay. I'm going to go ahead and move that over here because I did not give myself enough room for this. And then you're going to go ahead and solve for x. So I have to add 3 to both sides. And then divide by 3 to get x by itself. So then I have x equals 5. Okay? So I've found the value of x, which is 5. So if I have the point 1, negative 4, and 5, 8, I can actually find the slope and it'll give me 3. All right, number 2 looks a little scarier because our slope is a fraction, but the process is completely the same. Okay, you're going to do the same exact thing that you've been doing, or the same exact thing we just did. So I'm going to go ahead and copy my slope formula down again. And then we'll go ahead and label my points. x1, y1, x2, y2. Okay? And then our slope here is our m. So go ahead and fill it in. Negative 4 divided by 5, or 4 divided by negative 5, again, they're the same thing, equals y2, which is negative 2, minus y1, which is a 6, and then x2, 7, minus x. Okay? Go ahead and simplify that. You always want to simplify before you cross multiply. So we have negative 2 minus 6, which is a negative 8. And then 7 minus x in the denominator. All right, here you're going to cross multiply again. So I'm going to go ahead and do this guy first. We have negative 4 times 7 minus x equals, let's use pink, 5 times negative 8. Well, 5 times negative 8 is going to be negative 40, okay? And then the next step here is going to be to distribute. Negative 4 times 7 is negative 28. Negative 4 times negative x is a positive 4x. Okay? Now I want that 4x by itself, so I'm going to go ahead and add 28 to both sides. So then I have 4x equals, what is that supposed to be? I think negative 12, I believe. Yes, it is. All right, and then we can divide both sides by 4. And we have x equals negative 3. All right, so go ahead and box that. So here our x value was negative 3. Now again, you're not always going to be solving for